In this video, we're going to learn about how to find a transfer function from the state equation and output equation. So here we know that x dot equal to ax plus bu, that's the state equation, and y equal to cx plus du, that's the output equation. Now we want to find transfer function, which is h of s in S domain, y of s over u of s, assuming initial conditions are 0. That's a transfer function, definition of a transfer function. Now, from these two equations, which are state and output equation, we need to find this. Now, this x dot ax plus bu, I'm converting that into S domain. X dot in S domain, s times xs plus equal to, ax of s, b u of s. A and b, those are matrices mostly with constants. So if I bring the axs other side, it's going to be s minus a x of s equal to b u of s. Now a is in a matrix format. I mean, based on the state variables, you may end up with a 2 by 2 matrix or 3 by 3 matrix, something like that. Now s is a scalar quantity. You cannot subtract a scalar quantity, a matrix from a scalar quantity. So what I'm doing, I'm converting the scalar into a matrix format by multiplying that with I, identity matrix I. So Si minus A, we know that if x times I is nothing but I. If you multiply something with the identity matrix, you will end up with the same thing. So that's the reason I'm multiplying this with identity matrix. So Si minus A x of s equal to b u of s. Now x of s is nothing but, if I bring it to the other side, Si minus A whole inverse times b u of s. Now y of s is nothing but c x of s plus du of s. Now I'm going to replace this x of s with Si minus A inverse times b u of s. So c times Si minus A inverse times b u of s plus du of s. Now if I pull out the u of s, y of s over u of s, which is h of s, is a transfer function equal to c times Si minus A inverse times b plus d. That's the transfer function. This c times Si minus A inverse times b plus d is also called characteristic polynomial equation. I mean, when I make it equal to 0, it's going to be equation if I make it equal to 0, or if I don't make it equal to 0, it's just characteristic polynomial. Now I'm going to solve a simple example here. X dot, so state equation is given and output equation is given. X dot equal to minus 3 1 minus 2 0, that's A matrix. So this is A, that's B matrix is 0 and 1, C matrix is 1 0, and D matrix is none, 0, nothing is given. So from the state equation, output equation, we are finding transfer function. So step 1, we'll find Si minus A. So Si minus A, S0 0s minus 3 1 minus 2 0. So s plus 3 minus 1 2s. Okay. Now Si minus A inverse. To find Si minus A inverse, for a 2 by 2 matrix, it's easy. Say for example, if x equal to ABCD, x inverse is nothing but AD minus BC times D minus B minus CA. So if I apply the same principle here, 1 over s times s plus 3 minus of minus 1 times 2, and D term is going to be here, D equal to s here, and B is minus 1, C is minus of minus 1, which is positive 1, minus 2 here, and A term is s plus 3. And now we're going to do C times Si minus A inverse. We are multiplying two matrices. Matrix one is this is 1 by 2, that's the size of the matrix. This is 2 by 2. Okay, we can multiply two matrix, so it's 1 by 2 and 2 by 2. Okay, we can multiply these two only if these two are same, then only we can do. and the result is going to be, the size of the resultant matrix is going to be 1 by 2. Okay, so for the matrix multiplication, I'm not going too deep into it, but if you have any questions, let me know. I can make another video on the matrix multiplication, addition, subtraction, those things. Okay, so this is 1 by 2, this is 2 by 2. I end up with a 1 by 2. This times 1. Now C times Si minus A inverse times B. So here also this is 1 by 2, this is 2 by 1. So for sure we can multiply these two as long as these two are equal. Okay, and the result is going to be, size of the resultant is 1 by 1. So that's how we end up with. Okay, so h of s, the transfer function, we derived transfer function from the state equation and output equation, s square plus 3s plus 2. This is what the transfer function. Now I'm going to solve one more example. So here x dot equal to 3, 0, 0, 2, x1, x2 plus 2, 1, u, and y equal to 1 minus 1, x1 and x2. Now we're going to find, first step 1, find Si minus A. Okay, so which is nothing but S00 S minus A 3002. So Si minus A is S minus 3, 0, 0, S minus 2. Okay, now Si minus A inverse is nothing but 1 over AD minus BC, which is S minus 3, S plus S minus 2, sorry, this is S minus 2. S minus 3, S minus 2 minus 0. Okay, now D minus B minus C A. I mean, if I choose this as ABCD matrix. Okay, now I'm going to multiply this with C times Si minus A whole inverse equal to 1 over S minus 3, S minus 2. I have C as 1 minus 1, S minus 2, 0, S minus 3. So I'll end up with 1 over S minus 2, S minus 3. So 1 time S minus 2, this is 1 by 2, this is 2 by 2, I'll end up with 1 by 2. So it's going to be S minus 2 and minus of S minus 3. Okay, now the last part, C times Si minus A whole inverse times B. Okay, so I will keep this separate, S minus 2, S minus 3. Here I have S minus 2, that's one term, minus of S minus 3, that's another term. And I have B as 2 and 1. Okay, this is 1 by 2, that's 2 by 1, so we can do the multiplication. So we'll end up with 1 by 1. That value is 2s minus 4 minus s plus 3 over s minus 2, s minus 3. Okay, so after simplification, I'll end up with s minus 1 over s minus 2 and s minus 3. This is the transfer function. Okay, so with this, I'm done with this chapter, but I'll try to post more examples, solving examples, finding for transfer function or finding for state equation, output equation, and next couple of videos. Okay, thank you.